Hello everyone, welcome to the lecture 2 of EC 573 Advanced Embedded Logic Design Winter 2022 semester. In the last couple of videos, we discussed about the hardware software co-design. We discussed about the need of the flexible communication standard for the system on chip bus. And then we discuss about the various standards, and now we are going to focus on the one standard, which is the AMBA, that is the Advanced Microcontroller Bus Architecture. As we know, AMBA, that is the Advanced Microcontroller Bus Architecture, was developed by company ARM. It was released around 1995-1996, around that period. It is an open free standard. In AMBA, there are multiple versions until the second last version, that is AMBA 4. It is an open standard responsible for the on-chip communication and management. It is inside all the ARM SoC, whether it's a processor or the microcontrollers. This AMBA standard is used, and that is why we are also going to study the same. And since ARM has been widely used in the mobile phones, tablets, and all the mobile devices, that means AMBA has been well used as well as well tested there. So to understand the evolution of AMBA, so you can see that in the 1995, the first version of the AMBA was proposed, and it consists of the two buses. One is the Advanced System Bus, ASB, and the second is Advanced Peripheral Bus, that is the APB. So in a SoC, you usually have the slow speed peripherals and the high speed communication between the memory and the different units inside the SoC. So you use the APB to communicate with the peripherals, which are the low speed, and ASB to communicate with the memory and the other component. Then after 4 years, in 1999, there's the next version of the AMBA was released, which is the AMBA 2. In this case, they have extended the APB to APB2, and then they replace the ASB with the AHB, that is the Advanced High Performance Bus. Then in 2003, they come up with the next version of the AMBA, that is the AMBA 3. So this version came in 2003. In this case, they extended the APB. Then they have another version of AHB, that is the AHB Lite, which is the lighter version of the AHB in terms of the complexity, but also it supports the fewer number of features. And then they came up with the AXI, that is the Advanced Extensible Interface in the AMBA 3. So in this AXI protocol was developed to support the high data throughput application, and somehow there is one thing is missing, which is the ATB, Advanced Trace Bus. This was also included in the AMBA 3. Somehow it is missing here. So this Advanced Trace Bus is used for the debugging purpose. So it is using to move the trace data from the processor on your software, so you can use the data. You can apply the breakpoint and see what is the current status of the processor registers and other units in the real time. That is the Advanced Trace Bus. Then in the AMBA 4, the APB was extended. AXI 3 was improved further to the AXI 4 to get the better performance in terms of the throughput, as well as to support the multiple master, multiple slave. And in the AXI 4, it was divided there were two more versions were proposed, AXI 4 Lite and AXI 4 Stream, which we are going to study. But the main aim was to support the flexibility of the communication protocol. Similarly, subsequently, as your processors became more complex, you have the multiple cores, multiple cache, then multiple processors inside the SoC, then the coherency of the data was also an important factor, and that's why they came up with the ACE, that is Advanced Coherency Interface. So this is the protocol they developed, the ACE, that is the AXI coherency extension, that extension of the AXI to the coherency. And now recently they came up with the CHI, that is the coherent hub interface for more advanced ARM processor. So when you are studying about the MPSoC, hopefully in the end part of the AELD, we may discuss about the ACE and the CHI. So this slide gives you the about the in which processor or in which ARM processor which protocol is being used. So you can see that this AHB, ATB are widely used in the Cortex-M for low resource processor or microcontroller, while in the Cortex-A9, which is the application grade processor, you can see that they use, along with this one, you use the AXI, and this is the AXI 3. While in case of the FPGA or the advanced ARM processor, they use the AXI 4. Okay, so these are the AXI 4 and these are the extension for the coherency part. So you can see that in our case, we have the FPGA as well as the ARM processor, which is the Cortex A9 and the FPGA. So we are going to study the AXI 4 because AXI 4 is a better version of the AXI 3. Though our processor used the AXI 3, but there are automatic units which are there inside our SoC, which converts the data from the 3 to 4 and 4 to 3. That is, so we don't need to study the AXI 3. Okay, so this is all about the different AMBA protocol. So inside the AMBA protocol, we are not going to study during the lectures about the ATB, AHB, that is your quiz 1. But what we are going to study is about the AXI 4. And later, if we get time, we will study about the ACE or CHI. So this is your take-home quiz where you need to understand the basics of APB, AHB, and AHB light protocol. To understand this, you should use this book, System on Chip with a Design Cortex-M processor. I'll upload it on the Google Classroom. In this, there is a one chapter which discusses all this protocol. If you need more information, you can look at the ARM website for the additional material, or you can look out the AMBA handouts. And there are few videos available online which you can also look at to get the understanding. So what is the deliverable? You need to prepare a presentation and 8 to 10 minutes of video on each protocol to discuss the what is your understanding about the each protocol, and specifically what is the difference between the each protocol. Make sure you discuss the timing diagram and how the write and the read transaction takes place. Then what is why we are doing the quiz 1? The first thing is that it will need to be done in a group so that it will start your project group interaction. You will know whether this project is feasible for me, whether I'll be able to work with my project members. So that is the one thing you will get understanding before we actually start working on the project. Second, you will understand the basics of the protocol because these protocols are simple, and we will be studying the AXI4 protocol, and you will see a lot of similarity between these protocols. So you will be able to understand the basics of protocol. You will understand how the problems which we have discussed are addressed in this protocol. And the thing is that you will also aware about what are the challenges happens in the self-study, because when you have to do some self-study, when you want to learn something on your own, you need to spend a lot of time. So suppose that tomorrow I told you to learn the AXI4 without giving the lecture, you will see that how much efforts you need to put. And that's why you will also hopefully understand the importance of the lecture or the topics we discussed during our lectures and the labs. So going back to our discussion on the AXI protocol. So AXI stands for Advanced Extensible Interface. It is one of the several protocol as we have discussed. Why we are using it? Because in our hardware, which consists of the ARM processor and the FPGA, where the AXI protocols are being used. So now I think you are more or less convinced why we need to have the common flexible protocol, because availability. By having the common availability of the one protocol, if everybody start using that protocol and making their IP, compatible with the corresponding protocol, the sharing it over the other people becomes very easy. So you can have the worldwide community of the access to the various IPs developed by the anyone in the world. For example, FFT, DOI estimation, any algorithm you want to use in your hardware, and if someone has already developed that IP, and if you understand that protocol, you will easily use it in your product. Productivity. As an engineer, if I ask you to study about the AMBA protocol, Core Connect, Wishbone, your entire semester will go away. But now, what we are doing, we are now moving to the one standard or one popular protocol. By using the one standard protocol, you can see that as a developer engineer, you need to study only one protocol. So that means you can have your productivity will be increased. If you are working in the industry and if you are inside the SOC, if you are using the 3 different protocols, you need to understand all these 3 protocols, and then you need to have the models to convert data from one protocol to another. That is, then you will spend a lot of time on the interface instead of the actual algorithm. So your productivity will go down. So having the common protocol will help. And again, this AXI protocol is flexible. What? Because as we have discussed in the previous slide, there are 3 parts of the AXI. AXI4 and AXI stream and AXI lite. So it provides the right protocol for the particular application. And that's why AXI protocol is important. And as I told you, between the processor and the FPGA, the communication happens over the AXI protocol. So you can see that here everything is AXI protocol. So we don't have any choice without the AXI protocol.